line segments. And then I think we talked about rays also. You mentioned collinear and coplanar. So, so two rays from the same point make an angle.
All right, two rays from the same point make an angle.
Yeah, that's sort of the pure definition of it. Now, a couple of different types of angles. Acute is when the angle is less than 90 degrees.
All right.
Okay, and 90 degrees is a right angle. So you're sometimes you're just eyeballing it, but I think this one's pretty clear that this is acute. There's also what's called a right angle, which is exactly equal to 90 degrees. An obtuse angle, which is greater, greater than 90 degrees, but that's a little bit, that's not really a complete definition. It has to also be less than 180 because there's what's called a straight angle, which is 180 degrees.
Oh yeah, straight.
Yes. And so this is kind of a point here of emphasis is that if you imagine, I wish I could sort of rotate this thing, but if you imagine an angle rotating, when it gets here, it's straight. But as soon as it comes back over this horizontal, like let's say it goes here, you're now measuring it this way. You're no longer measuring it that way.
Okay.
So the point, I guess, is that angles are always less than or equal to 180 degrees. You wouldn't say, oh, it's 200 degrees, which kind of not true, but for now we'll just say that. So
We'll just go with it.
yeah. So this terminology is somewhat important. The instructor might say, draw an acute angle. Well, draw an acute angle, and they might say to draw an obtuse angle. So an obtuse angle, this is an obtuse angle. Now you got to put the arrows on the end. We'll go D, E, F. Okay. And usually have a little angle symbol next to it. Right.
E, F.
Now, very important is that middle letter is always
the
vertex. Yeah.
I think that's the one thing I got from class last week.
Yeah. Now, this angle right here could also be referred to by a single letter, angle E.
E.
And the reason is because there's nothing else coming out of E, but the angle is between 0 and 180. It wouldn't be the other way. So there's that. The other possibility, and I'm just showing you examples here, is that I could label an angle with a number. I could say that this is angle 2 right here. And I'm not referring to its measure. I'm not referring to its rotation.
One, sort of.
Yes. Now, this runs into issues, and this is where I remember there being some homework in your book. So let me label some things here. Let's go X, Y, Z, W, Y, V. So if I say, what is the measure of angle Y? If I asked you this on an exam or quiz, the question is, well, which angle are you referring to, Matthew? And you could actually give me a couple of options. You know, why you're referring to that one? Okay. And the answer is, well, maybe. Now, this angle up here and this angle down here, these are called vertical angles.
All right.
And vertical angles are congruent.
Vertical angles. Congruent.
The truth is, angle Y could also be referring to this over here on the left. I'm sorry, the right, and then the left. And those are also vertical angles.
So vertical, okay, so the ones that are going like horizontally, those are still vertical because it's like going up and down, or
they're vertical because they're on the opposite sides of the vertice.
Okay. Oh, right, the vertex is the middle of this.
Yeah. So let me give you a numerical example to make this more clear. Apologize if you need to write these notes down, but let me give you a numerical example here. So let me draw a straight line. The measure of this straight line is 180 degrees. Now I'm going to just go up here and just because I'm going to guess this is about 70 degrees right here. if this is x, x plus 70 equals 180 degrees.
Uh-huh. So
Okay.
am I figuring out what, like, would it be 110?
Yes, x is 110 degrees.
Okay,
Okay.
so X is like figure out what the missing point is, sort of.
Yes. Now, if I draw this vertical line down further, okay, you'll see now what I mean by vertical angles. This one is 70 degrees. Well, why is it? Well, because this one that's going straight up and down is a straight angle. 110 plus, let's call this y down here, it's 70.
Uh-huh.
Well, that's obviously going to be 70 degrees. If you call this y over here for the moment, you could say 70 plus y equals 180. So y equals 110 degrees.
Okay.
Okay, so this is always true when you have sort of two lines intersecting like this. And it's got to be two lines intersecting. Okay.
Mhm. So there's
That's
going to be an X and a Y when there's a lines intersection.
you can choose. No, you can arbitrarily choose those. That's not important. What's important is that you see that the angle measure up here is the same as this one down here.
Oh, okay.
One up here is the same as this up here. So like a silly exercise, but we'll do it here. Let's say this is 30 degrees. What is
Mhm.
x, y, and z? What is x? What is
Um,
y? And what is z?
I think X is 180.
Well, x plus 30 is 180,
Oh, 150.
150 degrees.
So then that would mean that Z would be 150 and Y would be 30.
Perfect.
All right. And then would I have to make like a line on there saying like the vertex at all or anything? Or
Say that one more time.
would I have to like make a line saying like the vertex is on there or something too? Or I mean,
No. I mean, you could put a dot there if you want, but no. The point is like that if I give you one angle, you can get the other three.
okay. Okay. All right. That makes more sense actually.
Okay.
So we know that we know that line going horizontally is 180 degrees. We
Well,
have,
so is this one going diagonally.
yeah. And
Just
we
you might have
know,
to, yeah.
and that's because the line's straight, right?
Yes.
Okay. And we know it's 180. We're given one of the spots, which is 30. And then we're like, oh, we can figure it out from there. What makes 180 from 30? And then you just figure, and then it just copies itself.
Yes.
Okay. All right. That makes more sense.
Okay. So there's kind of a couple of like math commandments or geometry commandments, things that just over and over again you see in geometry. One is that you set things equal, and I'm being very general with this word things, which I don't really like.
Uh-huh.
I actually had an instructor growing up, and if you said the word things, stuff, or junk, I think you had to like you owed a donation to the end of the year party because the instructor wanted to be more specific, and they were right. But things refers to so much in this course that I don't want to quite
Get
you know
comfortable using it.
yeah. But the key word you want to focus on here is equal. So you're going to be setting something equal to something a lot in this class. Okay. The
Mhm.
other thing is they add up to something. Okay. And this is we're going to talk about complementary angles. Do you remember from class what complementary angles, what they add up to?
Um, they add up to um, well, I guess 90 degrees.
90 degrees, yeah. And then supplementary angles,
Also add up to 90 to make
they
180.
different add up to 180 degrees.
Okay.
And these are important. So there's a lot of definitions in this class. I mean, we've covered already points, lines, line segments, rays, angles, straight, vertical angles, tons of like memorization, things you've never seen before,
Mhm.
things that, you know,
Supplementary. So, do you just recommend like flashcards and stuff like that to memorize all this?
yeah. In your English classes, do you get like vocabulary lists each week?
Um, Thankfully, no,
Okay.
but
Okay. It would be the same idea, whatever you do to learn some vocabulary.
Okay.
Oh, we talked about acute, obtuse, right, all that stuff.
Mhm.
All right, so now, like, why is this important? Because I could tell you the measure of angle A equals 36 degrees, and then I would say the measure of angle A, or I'm sorry, let me actually, I would phrase it differently. I would say angle A and angle B are complementary.
So all right, so they both add up to 90. So that means they'd be A
So,
would
and
be 45 and B would be
no,
45.
no, nope. A is 36. They could be
Oh.
equal, but I'm asking. But the mask. What is the measure of angle B? That's your question.
Um.
And here's the picture if you want, if you need one. So measure of angle A is about 36 degrees. There's the angle B. They make a right angle, so they add up to 90.
90.
X plus 36 equals
90.
90.
So with okay, so then I could just subtract 36 from 90 and that would
Exactly.
okay, and then that would get me 54.
Yes.
Okay, so will I ever get lines and like graphs or like I don't want to call them drawings, but like I guess drawings of like an angle and I'm not actually given like the measurement of anything, but I have to like figure it out from there. Or
Yeah.
is
So
that
there,
like
so if this is your geometry course right here, I'll kind of outline what you're going to see. You're going to spend somewhere between a third and a half of the course doing proofs. Okay.
mhm.
And that's in the first semester. So if we draw that right here, and then you spend a tiny portion of the first semester doing what are called compass and protractor exercises. So they teach you these things called constructions, which are like, here's how to create a right angle, or here's how to bisect an angle, or here's how to bisect a line segment. And that's why you were asked by a compass and a protractor for this course. So
Okay.
to answer your question, like no, you're not going to be asked to like make a 36-degree angle, but you might be asked to make a 45-degree angle, because the
Mhm.
45-degree angle is a right angle that you bisect, and you'll learn these techniques for doing that.
Mhm. Okay. And then, so I mean, yeah, like I know 180 and 90 and 45. Is there any other like,
No, those are the big ones.
okay.
So let's say the measure of angle C is 33 degrees. What is the measure of angle D if angles C and angles D are complementary?
So M to C is 33. Um, okay, so I should make like a two lines and then so complementary is 90 degrees and then that would be 57 degrees for
Yes.
E.
Yes. 57 degrees. Good. And that degree symbol is really important because there is a difference between 57 and 57 degrees. So depending on your instructor, they can be really particular about this. I think you said you're still waiting on your instructor, so to be determined. Um,
Yeah. Hopefully this week, but not
yeah.
getting next.
So
Sorry, wait. So what's the differences with degrees on this? Like, some people might just write 57, and some instructors write.
yeah, so if you let's say this was well, I'd have to. I mean, I'm just sort of freehanding this, but if I wrote a question that says, "What is the measure of angle D?" and you wrote 57, it's like when you don't give units to
Uh-huh.
someone. Like someone might say, "Hey, I want you to pressure wash my driveway," and you're like,
Uh-huh.
"All right, that'll be two." And then do $2, $200, $2,000. I don't know. So the degree symbol is a very clear
Equal.
indicator. Now,
Okay.
not to be confused with, if you're taking chemistry, it's not the same as the degree symbol that you use when you're assigning temperatures.
Okay. All right. I'll just make sure to put it in just so.
Yeah, but it's more important. It's more important. Like, let's say you're talking about the measure, or let's say someone asks you for the length of line segment TM, and you put arrows like this. Length of TM is infinite, but the line segment TM might be fixed. It might be 3 inches. See how one's a segment and one's a line?
Uh-huh. Oh, right. There's the dots instead of the arrows.
And that's where you can run into trouble. You got to be very particular in this class.
Yeah.
Trying to think of some examples. There's kind of if we say generally, there's people who are very macro view, and this is very much like high level.
Uh-huh.
And there's other side is micro, which is low level. So they sometimes you hear the terminology like in the weeds, can't see the trees from the forest. This is the forest, and you're sitting there worried about a tree, and somebody's over here worried about the forest. So that's the difference. And this class is very micro level.
Okay.
You can't just say line, you have to say line segment.
Yeah. I like
You're going to prove that it's a triangle. You're going to prove that the segments are equal. And you can't just be, well, they look equal.
That just doesn't work.
That doesn't work. Yeah. All right.
So you have to be super specific when doing.
Yeah, it's very specific.
Okay. All right.
And that's what I think is frustrating for students, because they're like, what do you mean? Like, I've been told this is a triangle my whole life. What do you mean I got to prove it? Like,
yeah, I was kind of funny when I first saw. I was like, what do they even mean? So that you just do like an equation, right? Just to be clear.
yeah. Well, you'll get to proofs. If you feel confused now, proofs will everyone struggles with proofs. So let's do some things. Let me grab. I've got another angle picture here for us to look at. So this is a deceptive question I'm about to ask you. What is the measure of angle O? I'll give you a moment to see if you can figure that out.
180.
So let me give you some multiple choice here. These are all wrong. 18,
Okay.
72, 90, cannot be determined. So this goes to my earlier comment, which is,
oh, wait a second.
We don't know what O refers to.
Forever.
Well, no. We don't know what O refers to. We don't know if O refers to this or if it refers to this.
Oh, okay.
Okay. That's what I'm trying to show you here. And I'm not trying to be deceptive.
Uh-huh.
I'm trying to remind you that you have to be very specific about what you're referring to here. Okay. Okay, so let me try it again here. I'm gonna be much more clear about it this time. What is the measure of angle AOS? And it's a path. You start at A, you go to O, and then you come back to S. A to O to S.
A to O is 18 degrees.
It's not A to O, it's A to O to S. The angle is AOS.
Okay.
That's really important. It's 3 letters. Okay. That's what I was trying to show you in the previous problem. Like you might think that angle O is 18 degrees. It might be the 72. It might be the combination, or really it cannot be determined, because you have to use 3 letters to refer to an angle. Now, what is the measure of angle SOA? SOA.
18, I guess. No.
Yes.
Okay. So is that 18? That 18 is not representing a point on the line. It's representing the entire like angle of the triangle.
There's no triangle. It's not a triangle. It's just an angle.
Okay. Oh, because it's coming from the same points, and it's not triangle because they're not connecting at the top.
Yes.
Okay.
Is that okay? Is that clear?
Yeah, I think so. Maybe
Okay,
you have
we're gonna do
another
some
one.
more. We're gonna do some more. What is the measure of angle SOC? SOC.
72 degrees.
Okay. How about the measure of angle SOE?
Um, 72 degrees.
It's still 72 degrees. That's right. Very good.
Okay. All right.
All
Yeah, I
right.
guess. Yeah, they kind of give you the answer
Now, how
almost.
about the measure of angle AOC?
AOC, 72 degrees.
Try again one more time.
Oh, wait a second. You have to 90 degrees.
Yes.
Okay.
Because you're adding them up. It's 18 plus 72.
18 plus 72. Okay. All right. 18 plus 72. And then if you were to ask something like what's
I could ask, and this is the same value. I could say, what is the measure of angle COA, the measure of angle EOA?
mhm.
It's still that.
Okay. All right. Well, all right, yeah. I think I'm ready to understand that. Or sorry, I don't know how to word it really, but I think I got that. I think I got
Okay. So let's try another problem here. It's kind of related. All right, so this is R. I know it's not real clear here, and let's put something here. So let's say that this is 108 degrees right here. What is the measure of angle C?
72.
Okay, let's try again. It cannot be determined
Okay.
because we don't know whether C refers to this angle, this angle, this angle, this
Right,
angle.
right, right.
Okay, but what is the measure of angle TCE?
That would be 72.
That's 72 degrees.
Okay. All
What's
right.
the,
That's
what's
the
the measure of angle
clear.
RCE?
108.
108. And I'm not trying to trick you. I don't like
Yeah.
so-called trick questions.
I just understand
I
it.
want you to be very clear that you need three letters to indicate an angle.
Mm.
Or it better be very clear. Like I'll give you one that's clear. A, B, C. This is 60 degrees. This is 54 degrees. What is the measure of angle A? This is definitely A. Okay, now to do this, one of the second things is that all three angles in a triangle add up to 180. So A plus 60 plus 54 equals 180. That's your second geometry rule, is that a lot of times things add up to something.
Mhm.
Okay, so you could solve that equation for A.
So for A, so you don't need three letters for that one for it to
No,
be.
no, because it's very clear. But
Mhm.
and so A is measure of angle A here is 66 degrees. But let me so let me make a different picture, which is very similar. Here's A, here's B, and here's C. And we'll just put the same numbers in: 60 degrees, 54 degrees. What is the measure of angle A? Well, now, is it that one or is it the one right next to it?
Mhm.
We don't know.
Okay.
But if I say, what's the measure of angle BAC?
Then you would say 134.
Yeah. No, B
Wait, what am I saying?
no, it's still 66 degrees.
Yeah.
But if you want the other one, measure of angle, let me put another point out here. Measure of angle EAB, that's the 114
80.
degrees.
Okay, wait. So in order to get, so is it 66 because you add together the 60 and the 54?
Yes, in a triangle, the three angles A plus B plus C have to equal 180 degrees.
Okay.
So if B is 60 and C is 54, you can solve for measure of angle.
Okay, so ABC equals 180. That is a complementary angle. No, that is a supplementary angle, and you will add the two numbers together, and there will be one that's not there, and then you just can figure it out from there, and that's your answer.
Great.
Okay. And then, could I get another one like this, please?
Sure, but you understand to find angle A. You add them up and you find the missing angle, and then
Yeah.
if this is 66 degrees, well then this is a straight angle. The two angles have to add up to 180. So it's whatever, it's this x plus 66 equals 180. That's how I came up with 114. So
Okay, so I wouldn't be using. So if it's EAB
yeah,
on.
so let's do another one here. So we'll call this A, we'll just change the letters here to be difficult, C and D. And let's go with 48 degrees and then 72 degrees. I don't want you to find the measure of angle BC. I'm sorry. C, measure of angle CBD. Okay, go ahead and find CBD first for me.
All right. CBD 48 plus 72. B would be 60 degrees.
Yes, yes. And then what's the measure of angle ABC? That's the one, or this other one here.
C, if I know it's 60 and 48, then that's 108 minus 180. 172 would be for A, or 172 degrees.
But isn't oops, sorry, my screen just froze up here. Isn't this 60 degrees?
Oh, it wouldn't be 100 and so okay, here, wait, let me just actually write this one out. 60 and 48 equals 108. It would be 72, not 172.
For what?
The point of A.
No, there's no A. There's A to B to C. A, B, C. There's three letters for each.
For B?
No, there's no B. The B, we don't know what B is. C to B to D is 60 degrees.
Mm-hmm.
Because or I think that's clear. But to find ABC, x plus 60 has to equal 180.
So then it would be 120, and it's 180 because the line's just straight.
Yes.
All right.
Yes. Okay. To find this other one, I mean, you can write it as B. You could say B plus 48 plus 72 equals 180. That's fine. But you got to just be careful here. Okay, let's try another one here. I'll change the orientation slightly for this. Let's go E, D, C, B, and so I'm going to change up here. So let's go the measure of angle CBD equals 55 degrees. Measure of angle DCB is 35 degrees. Okay. And I want you to find the measure of angle BDC and the measure of angle EDC. So what is hard about this question that's different than the others is that I'm not labeling the angles. You now have to label the angles.
Mm-hmm. So C would be 55.
Nope, you can't say, you got to be really like I'm trying really hard here to emphasize you got to use three letters for the angle.
Okay, sorry.
Like, yes, it is C, but I would prefer you to say DCB or BCD.
Okay. BDC. Okay, so CBD is 55 degrees.
Yes. And which one is that? Is that angle 1, angle 2, or angle 3?
I think angle 3.
So the middle letter is the vertex.
Okay. Should be B. So then it would be number 1.
The middle letter is the vertex. So where's B? B is right.
Oh, number 2.
Yes. That's 55 degrees.
Okay, so then
It's a path, C
yeah,
to
so
B to
I just
D.
realized that the vertex is different on the one to the right of it for 35 degrees. So then
Yes, yes. Where is that one? Is it angle 1 or is it angle 3?
it is angle 1.
Again, that middle letter is the
Oh my
vertex.
god, sorry. Angle 3.
Yes, and okay, but we're uncovering something here. This is good because I'm
Yeah.
uncovering like you don't really understand that the middle letter is the vertex because you want to go right to D, but that's
Yeah.
not the case. So now,
I was seeing like first letter, put it there for
now
some.
for a variable, I'm gonna write angle 1 as D. D plus 55 plus 35 equals 180. So I want you to solve that for D.
Okay. $90.
Yes, D is 90 degrees. Good. Okay, so that's 90 degrees. Now, which of these two is that?
Um, that would be EDC.
So E to D to C.
Yeah.
No, that's over here on the left. So like somehow, and I'm not conveying it, E to D to C is this angle right here.
And that's not 180 degrees.
Well, it's not this angle in here. The angle that's inside is right here.
Uh-huh.
That's B to D to
E.
C. That's 90 degrees.
Okay.
Okay, I see some issues. Let's try this again.
All right. I have a better understanding a little bit
Yeah,
now.
that's okay. That's okay. We're gonna get it here. So here's a triangle. E F G, and we're gonna go angle 1, angle 2, angle 3. Okay, and if I tell you the measure of angle FEG is 48 degrees, okay, which angle number is that referring to?
FEG would be angle 3.
Yes, very good. So like, and if it helps, and this is kind of what I used to do is you sort of draw this huge angle to
Uh-huh.
indicate that one. Okay. Now let's do another one here. What's the measure? Let's say the measure of angle EFG is 62 degrees. Which one is that? Is it angle 1 or angle 2?
Angle 1.
So F is the vertex. So yes, it must be this one. This one up here. Perfect. Okay.
So then I'd add those together, which would give me
Sure. Yeah. If we wanted to find the other angle, yeah, we might as well do it. Let's find the measure of angle 2. So you're going to add these two together.
and angle 2 would be 70 degrees.
That sounds reasonable. Yeah.
And then that would be M is less than.
No, angle. This means angle.
Oh, okay, sorry.
Yeah, and yes, it does mean less than, but in this context, it means
Angle.
angle.
M angle um
Okay.
EGF.
Yeah, let me this is important because I just noticed this. So M, okay, here's how you would write this and say it. The measure of angle FEG. So you don't say M angle FEG. You have to say it this way: the measure of angle FEG. That's what this means.
Mm-hmm. Okay, I'm gonna write that down. F.
It's like a new language almost.
Measure sorry, is that angle the measure of angle?
That's what this little M means. It means the measure of, and
Angle.
then this next part is the angle FEG.
Okay. F. E. G. All right. Got that written down.
Great.
I think that makes doing it a second time definitely makes a lot more sense than
Yeah.
the first
Yeah.
time.
Because remember, like here's a, let me draw our picture again here, because this is important to, this is what I was trying to distinguish with you the other day. So let's go A, B, C. So I could ask you on an exam, I could say, what is the measure of angle A, B, C? And then I could also ask you for the measure of A, B.
So AB I'd write is
Well,
no
just in words. What is this in words? What is this with the line segment above it? I just told you.
that means
It means get a ruler out, and measure from A to B.
mhm.
That's what it means.
And then you'd say it's like, oh, it's 1 foot or like
Yes. Yeah. I mean, on my screen, it's about, I don't know, we'll say 3 inches or something, 3.5 inches. Now, the measure of angle ABC means give me the angle of this up here. And it's probably 62 degrees.
mhm.
But do you,
And
but there's a difference. Like one is asking for an angle, one is asking for a length.
so the
Angle,
line equals length.
yes. But
And
they're
then
both the measure. They're both the measure of an angle, measure of a length.
mhm. So for the one above it's like measure angle ABC. For the one below it it's just M then AB. Do you need an angle on it? Or
Here's what this is. The measure of line segment AB.
the measure of okay.
Now I am remembering something now. This is important also, is that on your first exam, they ask you to sort of somewhere they ask you to distinguish between the measure of an angle and the measure of a line segment.
Mhm.
And that's what I'm trying to get you to see, is that they're both possible.
Okay. All right. Both possible. So in this case, it
Like you could
having
but you would have to distinguish them. You would have to say something like the first one means measuring the angle. The second one means measuring the line segment.
all right. And I do have another question to that.
Yeah.
How did you figure out that it was like 62 degrees?
I just guessed it's around 60 because the triangle I made here is a pretty close to an equilateral, which means all the angles are the same.
Which means that they don't have to be like
Around 60.
33 or all be like 20 or whatever like that.
No, but let's think about that. So let's look at an equilateral triangle. If all the angles are the same, okay, x plus x plus x equals 180. This is 3x, so x must be 60.
Mm-hmm.
So in an equilateral triangle, which is yet another, definition card thing, all angles are 60 degrees.
Okay, that actually makes a lot of sense.
Yes.
And then could you even break it down more from there? Like
No.
x would be 20 angles or no?
Well, this is for triangles. We're just going to stick to triangles right now. We're not going to get any
Oh.
more complicated than that.
Yeah, probably a good idea. Okay, so should I start memorizing like all the different types of triangles and like their kind of measurements like that?
All the keywords, which I can do. I can go back here and um, I guess I can go back and maybe highlight the words that were most important today.
Okay, because I think I've written down most of them too. Like I've written down complementary angles, supplementary angles, and the measurement of angle FEG and the measure of line segment AB.
We didn't define it, but congruent means the same.
Mm-hmm.
Complementary, supplementary. Equilateral triangle. Yeah, that'll do it here.
All right.
So there's some other things in geometry. We don't, I mean, unless you got specific questions, I guess I was going to just move away and do some other problems from them. So there's some other problems in geometry that you might appreciate more, you may appreciate less. But like, let's say I give you the following. And I say, this is a pattern. And I asked you to describe the pattern. Actually, that goes there as well. Sorry, that will do it.
Oh, okay. So when I say it stays the same, then moves up by 1, then moves up by 1, then moves up by 2, and then by 3. So it's like going like up by 1. It's like going one more than the last every single time. Like then instead of going from.
Okay, what if I told you now that the next number is 13? How would that change what you think or say?
1 to 1, add 1, you add 1, you add. And you add. It's moving up by 2, and then.
So here's the next number.
1, 2, 3, 5, 7. Oh, it's just moving up by like 2 more than the last number. Would the next one be 31?
The next number is actually 34.
34. Okay. So if it goes from 1, 1, 2, 2, 5, 3, then 5, then 8, then would the next one be like 37?
Next one is 55.
55. Okay.
Okay, so this is called the Fibonacci sequence. It's the most famous one of them. And the way it works is you take the previous two numbers and you add them up. So then to get the next number, you add up 1 and 2. Then you take 2 and 3 and add them up. Then you take 3 and 5 and add them up. And then you take 5. Okay. And that's what it is. Now, you're not going to be asked this in your class, but this is a nice introduction into patterns. Okay. So here's one that you might get in this class. Okay. What is the next thing in this sequence?
Like the.
What goes right there? What would be next?
5.
5. And what would go next?
6. Or well, a triangle and then
triangle. 5 and a triangle. So pattern does not have to be just numbers. It can have shapes. In fact, it could even have all shapes. It could be triangle, square. Oops, I didn't mean to do that. Circle, triangle, square, circle, and so on.
Mm-hmm.
Okay. Now this is where it's going to be a little bit. This is kind of your quiz question. This is, what is the 13th shape? And start. This is 1 right here. Just to be clear, it starts at 1.
Right. So then you'd go 2, 3, 4, 5, 6. Excuse me. Square. Or here, I'll write it down so you don't have to. So then it'd be square, triangle, square, triangle, square. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It would be a square as your 13th.
Now, did you draw them out?
I drew out like half of them.
Okay,
Like,
because as soon as you draw it out, I'm just going to change this to ask you like the 130th, because the point here is not to just, it's to figure out the pattern. And we know that it repeats in threes. Okay, triangle, circle. I'm sorry, triangle, square, circle, triangle, square, circle, triangle, square, circle. We know that it repeats in threes. So like 1, 4, 7, and so on. See how that repeats?
yeah.
Okay, so let's do 130th. Okay, and I know that if we add, like 120 comes to mind. So if I go 1 plus 120, that gets me to 121. Okay, that's like that starting point right there. And if you don't know why that is, because 120 is divisible by 3.
Okay.
Okay, and just take my word for the moment. So that's 121, 124, 120, 127. So 130 would be a triangle. And the point is to not have you
Draw it out 127 times.
yes, because that would take too long. Now, the last kind of problem I will leave you with, or thought, because it's not just this. Here is another pattern that you might see. Could you describe this in words for me as
Um,
best you can, whatever you come up with?
it's it's getting a third bigger every single time.
So I like count the number of squares. How many squares do you see in this first one's 1? How many are here? Individual
Or
squares, small squares. How many small squares do you see?
4.
Okay, and how about this one right here?
I see 9.
Okay,
And then this one has 16.
so this and I didn't. It's 1 squared, 2 squared, 3 squared, 4 squared. So if I asked you for the, I don't know, 8th one,
It would be like 25.
it'd be like 8 squared.
Yes, it'd be like 5 and 5.
Well, the next one would be 5
Oh,
and
and
5,
8 squared would
6 and
be
6, and so on, right? So the
6 and 6.
patterns, and this is what the takeaway I want you to have is the patterns. There's numerical patterns, there's numbers and shapes, there's shapes only, there's growing patterns, there's lots of patterns.
Okay, so like I guess anything could be a pattern almost. Okay, so there's growth, there's length, there's shapes, there's numbers. I guess kind of anything can be.
Could be anything. Yeah. I mean, you can even do, fruits and vegetables, whatever. Like the point is patterns are patterns. So all right, so that's kind of it for today, Zach. I'm happy to do these lessons. I mean, I think they're really helpful. There is kind of more geometry, numerical content we can do. So
Mhm.
if you do want to schedule these more often, I would go back in that direction of like working on some stuff I think you'll see in the course. But
Yeah.
um, thank you so much for scheduling. I hope this helped, and I'll see you next time.
Yeah, of course. All right. See you, Matthew.
You're
Thank you.
welcome. You're welcome. Bye now.